All right, let's dive in. Today we're tackling aerogels.
Oh, aerogels.
And I gotta say, you really picked a winner for cocktail party chemistry.
Mhm.
Episode 55, The Lightest Solids in the Universe.
Mhm.
Now that's a title that'll get people talking.
Yeah.
I've got your 5 factoids right here, and I'm already hooked.
Ugh.
99% air. It's strong. Used in spacesuits and on Mars.
Yeah.
All right, color me intrigued. Let's break down what makes these things so special.
You know, it's always the stuff that seems impossible that turns out to be the most fascinating.
Right.
Let's start with that 99% air yet incredibly strong business.
Yeah.
I mean, that's what grabs everyone's attention with aerogels.
They're sure.
They look like wisps of smoke, but you can put a surprising amount of weight on them.
It's like you expect it to just, disappear when you touch it.
Right, like a magic trick.
Yeah, exactly.
But they're solid.
Yeah.
That frozen smoke nickname is so spot on.
Mhm.
You think about it. Most solids, they're dense, they're heavy because their atoms are all crammed together. But aerogels, it's all about the structure.
Okay.
Imagine you could swap out most of the solid stuff with air pockets, but in a very organized way. You end up with something that's mostly empty space,
Wow.
but the structure that's left, it's super strong for its weight.
So it's not about the material itself being strong, but how it's all arranged.
Exactly. It's like
It's pretty mind-blowing.
those incredible buildings where they use like the bare minimum of materials, but they get this amazing strength.
Oh, yeah.
It's all about those tiny interconnected pores that make up the aerogel's framework.
Right.
They distribute weight so efficiently. Now, think about that second factoid you had.
Okay.
Insulation king, used in spacesuits and Mars rovers.
Yeah.
This isn't just any insulation. We're talking top-of-the-line stuff.
Well, yeah, I mean, space is not exactly forgiving when it comes to temperature.
Right.
1 minute you're baking in the sun, the next you're freezing in the shadow.
And those temperature swings on Mars, even more extreme.
Yeah.
You need something that basically stops heat transfer as much as possible. And aerogels do this better than almost anything else because those tiny air pockets we talked about, they trap heat really effectively.
So it's like having millions of tiny little insulating bubbles all working together.
You got it.
Huh.
It's all about trapping air and slowing down that heat transfer on a microscopic level.
Okay.
That's why NASA used aerogel insulation in the Mars rovers, Spirit and Opportunity,
Oh, yeah.
protecting their sensitive electronics.
So they're like keeping our robots alive on another planet.
Imagine the challenge.
Yeah.
Keeping those rovers working through those crazy Martian temperature swings.
That's impressive.
Pretty amazing, huh?
Yeah, it's like the unsung hero of those missions.
Definitely.
But, we've been talking space, but your third factoid brings us back down to Earth with a very messy problem.
Oh, yeah.
Oil absorber. Can soak up oil spills effortlessly?
Mm.
Is it really that simple?
It might sound too good to be true, but it's one of those cases where the science actually delivers.
Okay.
And you guessed it, it comes down to those amazing pores again.
Okay.
It's like a sponge, but on a super tiny scale.
Huh.
Those pores can hold enormous amounts of liquid.
Okay.
And they have this thing about oil, chemically speaking. They just love to soak it up. So you can use aerogels to literally soak up oil spills.
That's wild. So we could use this super light, airy material to clean up like thick, heavy oil.
It does seem counterintuitive,
Yeah.
but it shows how versatile aerogels are.
Right.
They're already being explored for cleaning up oil spills because they can absorb so much compared to their own weight.
Wow.
Plus, you can reuse them,
Oh.
which is a big plus for the environment compared to some of the traditional methods.
Yeah, that's fantastic. Talk about turning a problem into a solution.
Yeah.
But I got to admit, the factoid that really grabbed me, the one that made me go, wait, what?
Yeah.
Is this impact resistant, stops bullets
Right.
despite being ultralight. I mean, we're talking about something that's practically air stopping a bullet.
Right.
How does that even work?
This is where it gets really mind-bending. It's all about how aerogels handle energy.
Okay.
Imagine throwing a rock at a solid wall. All that force is stopped instantly.
Yeah.
But what if you throw that same rock into a giant net?
Okay.
The impact is spread out over a much bigger area. The rock slows down gently. That's kind of what happens with aerogels. Their structure distributes the energy of the impact.
Okay.
So even though it's super lightweight, it can stop a bullet.
So it's like a force field, but made of air.
It's a tough one to picture,
It is.
but the science checks out.
Okay.
This has made researchers really interested in using them for things like lightweight body armor.
Wow. So we could have bulletproof vests that are like lighter than a feather.
It does sound a bit sci-fi.
It does.
Yeah.
But it sounds like we're just scratching the surface of what these things can do.
You're right.
And that brings us to your final factoid, which actually sums up everything we've been talking about. Frozen smoke appears ghostly due to low density. The reason aerogels look so ethereal, so otherworldly, it's because they're mostly empty space.
Yeah.
And it's that same quality, that incredibly low density, that gives them all these amazing properties.
Yeah, it is.
It's like we discovered a material from the future. It's strong, it insulates, it cleans up messes, and it might even stop bullets.
Right.
All because it's basically made of nothing.
Yeah.
This is definitely going to be a hit at your next cocktail party.
You think?
Oh, yeah.
I mean, we've barely scratched the surface of what aerogels can do.
Right.
There's so much more to explore, and I think we're just at the beginning of understanding their true potential.
Okay, so we are going to need to delve a little deeper into this incredible world of aerogels.
Sounds good.
We're going to talk about their potential applications, the challenges of working with them,
Right.
and maybe even get a glimpse into the future of this remarkable material.
Yeah.
So don't go anywhere. We'll be right back.
Okay.
All right, we're back, and I am still trying to wrap my head around how aerogels just, like, defy expectations. It's like they're the ninjas of the material world. Silent, invisible, and surprisingly powerful.
I like that. And we've only just scratched the surface of what they can do.
Okay.
Remember those tiny pores we were talking about?
Yeah, the ones that give them all those incredible properties.
All right, those pores. Well, they're not just good for insulation and soaking up oil.
Oh, really? What else can they do?
Get this. Energy storage.
Energy storage.
We're talking batteries and supercapacitors.
Wait, hold on. How do pores make for better batteries? I'm not following.
Okay, think of it this way. You have a flat surface and a sponge. Which one can hold more water?
The sponge, obviously.
Right, because it has all those nooks and crannies, all that extra space.
Yeah.
It's the same with aerogels. All those pores create a massive surface area inside. And the more surface area you have, the more space there is for chemical reactions to happen.
Oh, okay, I see. So we're talking about chemical reactions here.
Okay.
But how does that translate to batteries?
Those chemical reactions are what make batteries work. And supercapacitors, too.
Right.
So the more pores you have in an aerogel, the more space there is for those reactions to occur, which means more energy storage.
So it's like having a battery with millions of tiny pockets, all holding energy.
Exactly. And think about what that could mean.
Okay, well.
Smaller batteries, lighter batteries, more powerful batteries for everything. Smartphones, laptops, even electric cars.
Wow. That's a future I can get behind.
It is pretty amazing, right?
Yeah, but you mentioned supercapacitors. What are those?
Supercapacitors, they're like batteries, but they can charge and discharge energy way faster.
Oh, interesting.
They're great for things that need a quick burst of power, and guess what? Aerogels can make them even better by providing that huge surface area for all those super fast energy exchanges to happen.
So we could have electric cars that charge in minutes instead of hours.
That's the idea.
That's incredible. Are scientists actually working on this?
Oh yeah, there's tons of research happening right now looking at different types of aerogels and how to fine-tune them for energy storage.
Okay, I'm adding aerogel-powered supercapacitors to my list of things to be excited about.
It's a good list.
It is, but it sounds like a lot of this is still in the early stages. Are there any real-world applications of aerogels right now, besides what we already talked about? I mean,
Absolutely. Remember how we said those pores are great for soaking up oil?
yeah.
Well, they're also fantastic for filtration.
Filtration.
We're talking about filters that can trap particles as tiny as viruses and bacteria.
No way.
Yeah.
So we could use aerogels to, like, purify water and air?
Exactly. Aerogel filters can catch things that would slip right through regular filters.
Wow.
So they're perfect for a whole range of applications, especially with all the concerns about pollution and clean water these days.
I'm thinking air purifiers, water treatment plants, maybe even face masks that filter out, like, harmful germs.
All possibilities.
It seems like there's no end to what these things can do.
And the best part is, unlike some filters that get clogged up and have to be replaced all the time,
Yeah.
aerogel filters are super durable.
Oh, okay.
You can clean them and reuse them multiple times.
So they're not just effective, they're also good for the environment.
Exactly. Win-win.
Yeah, it is. And are there other uses being explored?
Oh, tons. Everything from soundproofing to drug delivery. It seems like every day researchers are finding new ways to use them.
This is starting to sound like science fiction. But with all these amazing properties and potential applications, what's the holdup? Why aren't aerogels everywhere?
That's a great question, and it leads us to some of the challenges that scientists are facing right now.
Okay, so what's standing in the way of aerogels taking over the world? What are the hurdles?
One of the biggest ones is their fragility.
Fragility.
They're incredibly lightweight and airy, which is great for all sorts of things, but it also makes them delicate.
Okay.
They can get crushed or damaged pretty easily if you're not careful with them.
So it's like trying to build a house of cards, one wrong move, and it all falls apart.
Pretty much. Researchers are trying to figure out how to make them tougher and more resilient, and it's a tricky problem to solve.
Yeah, I bet. And what about mass production? If they're so delicate, how do you make enough of them to meet all these demands?
You're hitting on another major challenge. The traditional way of making aerogels, it's time-consuming, it needs specialized equipment, and it can be quite expensive.
Okay.
Scaling up production to meet the needs of industry, that's a huge hurdle right now.
So we've got the science figured out, but now it's an engineering and economics problem.
Exactly. We need to make them tougher and cheaper.
Right.
But even with those challenges, the potential benefits of aerogels are just too big to ignore.
Yeah.
Scientists around the world are working hard to overcome those hurdles because they see the incredible value in these materials.
It sounds like we're on the verge of a major breakthrough.
I think so.
Once we crack the code on production, aerogels could completely change so many industries.
It's exciting to think about, isn't it?
It really is. But let's shift gears for a moment. I'm curious about how these amazing materials are actually made.
Right.
Give me the behind-the-scenes look at how scientists conjure up these frozen smoke wonders.
The alchemy of aerogels, it's a pretty fascinating process and maybe not what you'd expect.
Okay, take me into the lab. What's step one in creating these things?
So, are you ready to get into the nitty-gritty of how aerogels are made?
Lay it on me, I'm all ears.
Okay, well, it all starts with something called sol gel.
Sol gel.
And you weren't too far off with that Jell-O comparison earlier.
Yeah.
It does involve turning a liquid into a gel.
Okay, so I'm picturing a scientist, mixing bubbling potions in a cauldron.
Maybe a little more high-tech than that.
Right, of course.
But the basic idea is similar.
Okay.
We begin with a liquid solution called a sol,
Okay.
which has all the ingredients for our aerogel. And those ingredients are carefully chosen depending on what properties we want in the final product.
So it's like a recipe, but for a super advanced material.
Exactly.
And the sol is like the batter before it's baked.
Yeah, I like that analogy.
Okay.
So then, through a bunch of chemical reactions, the sol starts to transform into a gel, just like how gelatin sets into jelly.
Right, right.
Now, this gel, it's still full of liquid,
Yep.
but it has the basic structure of the aerogel we're going for.
So we've got this wobbly gel, but how do we go from that to something that's 99% air and can stop a bullet?
That's the million-dollar question, right?
Yeah.
And this is where the fun really begins. The next step is called supercritical drying.
Supercritical drying. Okay, I'm already lost.
It sounds complicated, but the idea is pretty simple.
Okay.
Imagine you have a wet sponge, and you want to get rid of all the water without squishing the sponge. That's basically the challenge with aerogels.
Okay.
We need to get the liquid out of the gel without messing up that delicate pore structure.
That sounds impossible. It's like trying to remove the air from a balloon without popping it.
Right. It's a real head scratcher.
Yeah.
But that's where supercritical drying comes in.
Okay.
It's a process that uses high pressure and high temperature. And we can actually transform the liquid inside the gel into something called a supercritical fluid.
A supercritical fluid. All right, now we're getting really sci-fi.
It's pretty cool. It's kind of like a state of matter that's halfway between a liquid and a gas.
Oh, interesting.
It has properties of both, which lets us remove it from the gel without disturbing the structure.
So it's like we're gently evaporating the liquid, but without any bubbling or boiling that could damage those pores.
Precisely.
Wow.
And once that supercritical fluid is gone, what we're left with is a solid, airy structure, our aerogel.
It's like turning a delicate souffle into a solid structure without it deflating.
That's a great way to put it.
It's incredible, but this whole process sounds very high-tech and complicated.
It is a delicate process, for sure.
Are there any, easier ways to make aerogels?
Well, scientists are always looking for ways to make things more efficient and cost-effective.
Right.
There are some new techniques being developed that don't need supercritical drying, which could make aerogels much easier to produce on a larger scale.
That's exciting. It sounds like the future of aerogels is very bright.
I think so, too. There's so much potential there.
Yeah, it's been fascinating learning about them. But as we wrap up, what's the one thing you want our listener to take away from all of this? What's the big takeaway about aerogels?
I think the most important thing to remember is that sometimes the most unexpected solutions come from the most surprising places. Aerogels are a perfect example of that. They're made from simple ingredients.
Right.
But with a little bit of scientific magic, they become something truly extraordinary.
It's like a reminder that we need to keep thinking outside the box, challenging our assumptions about what's possible.
Exactly. And that's a message that's always worth sharing, whether you're at a cocktail party or just chatting with friends.
Absolutely. So to our listener out there, next time you want to spark up an interesting conversation, just mention aerogels.
Oh, yeah.
Tell them about the frozen smoke that can stop bullets, clean up oil spills, and might even power our future.
And don't forget to mention that crazy manufacturing process.
Of course not. Thanks for joining us on this deep dive into the world of aerogels.
It's been a pleasure.
And to all our listeners, thanks for tuning in. We'll catch you next time.